All right, in lesson 6C, we're going to talk about making decisions using data. It said examine the 3 advertisements below. Identify the measures of central tendency that appear in each ad. How are these measures of central tendency used in each ad? Well, first, we probably better talk about, we're going to talk a lot more about these in just a minute. Central tendency usually means one of the 3 things: the mean, which is what you think of as the average, the median, that's the value in the middle, and the mode. The mode is the most frequent. You can also sometimes think of it being where you find a peak on a graph. So the first is sales positions available. We have immediate need for 5 enthusiastic self-starters who love the outdoors and who love people. Our sales people make an on average of 1,000 per week. So here they used an average or a mean value. Remember, that means some people may make less than 1,000. Some will make more. Second one says, are you average? Our company is hiring 1 person this month. Will you be that person? We pay the top percentage commission and supply leads. Half of our sales force make over $3,000 per month. If half make over $3,000 per month, that means half make less than $3,000 per month. They're using a median. This is Need a New Challenge? Join a super sales force and make as much as you want. 5 of our 9 salespeople each closed 4 homes last month, and their average commission was $1,500 per sale. Do the math. This is the job for you. Well, look, they used an average commission. That again is going to be a mean. It says 5 out of 9 closed. Okay, there's a lot of data there, but this is the central tendency. Let's look a little closer at those central tendencies. Make sure we know what they are. It says we need to understand each statistic. Mean, median, and mode is a different measure of the center for numerical data. Okay, we can use those measures of central tendency to make decisions. All right, I just want to make sure we know what they are. Let's make a data set. Let's suppose these are test grades. 50, I'm going to put them in order. 55, 65, 70, 70, 80, 85, 85. I'm going to add another 70 down in here. Let me see. Change it just a little bit. Whoops. Get my eraser. Change just a little bit. Put something interesting in this. 70, 70. I'm going to let 4 people make 70. 80, 85, 90, 90, 100, 100, 100. How many good test scores? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Double count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to change one of these numbers just because I want something. I'm going to change this one. to 95. Okay, so we have 15 values. If I have 15 values, it's an odd number. If I subtract 1, half of 14 is 7. So I know there's 7 values below. That's the first 7 values. And there's 7 values above the median. Right there is the median. The median, in this case, is equal to 80. If I said the median score is 80, you know that half the students made above 80 on the test and half of the students made below 80 on the test. That's the middle point. If I want to get the mean, I need to add all of those test grades up and divide it by 15 because 15 students took the test. So get out my calculator, 50 plus 55 plus 65 plus 70 plus 70 plus 70 plus 70 plus 80 plus 85, 90, 90, 95, 100, 100, 100. That's 1,190. If I divide that by 15, I see that the mean grade is 79. Actually came out to be 79.3, just a tiny bit. The mode is the most frequent. So in this case, the mode would be 70. We've got 4 scores that are 70, more than any other. That was the most frequently occurring grade. So just want to make sure everybody understands the 3 different measures of central tendency. There are some other measurements that we might talk about. The range is the difference from high and low. So for this case, the highest value is 100, the lowest was 50, so the range was 50. There was a 50% spread from the highest value to the lowest value. All right. Another thing I just kind of want to review is, what did the shape of the data mean? Symmetric means that if you fold it down the middle, it looks the same. That's that bell curve. When something's perfectly symmetric, we would kind of expect to find the mean, the median, and the mode all really close. They may not be exactly the same, but they'd all be really close up here. If the data is skewed one way or the other, let's do data that is skewed right. Skewed right means the peak is on the left. It would look something like this. It goes up, and then it just drags on slowly. Your mode may be over here. Your median perhaps over here, and your mean maybe even farther over here. When you're skewed right, it means the mean is right of the median. Typically. Definitely right of the peak. So maybe I should say it's right of the mode, maybe even a better way to say it. This value occurs the most right here. If something's skewed left, it means that we may have a lot of values down here before we reach a peak up here somewhere. Again, this looks like my mode. Typically, the median would be a little farther, and the mean might be all the way over here. When we are skewed left, the mean is left of the mode. It's usually left of the mode and the median. When you're skewed right, it's typically to the right of both the mode and the median. I just want to make sure you kind of understand those different shapes to help us. So we have a lot of vocabulary: mean, median, mode. We know that when we're symmetric, when we have that bell shape, all three of those tend to be right in the middle. When we're skewed right, our peak is over here at the left. We usually have a hill on the left, but our median and our mean are going to be farther to the right because of this long tail to the right. When we're skewed left, again, our mode we think of as being at the peak, but our median and our mean will be further to the left because of the long tail to the left. All right, let's move on to box plots. They used to call these box and whisker plots when I was a kid, and I think some textbooks probably still do. Since the data set shown is from a realtor report of the prices in thousands of all the homes sold in 1 month in a small city. It says place the sales prices in order from smallest to largest in one long horizontal row on your paper. Do you notice anything interesting? Well, we're not in a classroom, so I'm not going to ask you to stop and put all of that data in order. I thought I had a set. There it is. There's the data all in order from smallest to largest in one long horizontal row. Do you notice anything interesting? You may or you may not. I think the one thing that I notice, if we come over here, this house at $550,000 is more than twice as expensive as any other house. It's 11 times more expensive than this $50,000 house. So it kind of stands out. It says the range equals 500,000. The data has a large spread caused mostly by the atypical home, and this should be one word here, atypical, which means not typical, home that sold for $550,000. The median selling price is $125,000. Let's see if we can get that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's even. So let's do 1, 2, 3, 4, 5, 6, 7. So right here, those two, if I average 121 plus 129 divided by 2, I get a median that is 125. The mean selling price, if I added them all up and divided by 14, is $151,642.86. It's higher than the median, so it skews right. So the mean is going to be on the right of the median. All right, it says determine the 5-number summary which consists of the following values: the median, the smallest number, which is the minimum, the largest number in the set, that's the maximum, the median of the lower half, that's called the first quartile, Q1, first quartile. The median of the upper half is called the third quartile. It says create a number line like the one shown below and mark each of the values from question 3 with a vertical hash mark. So let's go back. Let's see if we can get the rest of these numbers. We need the minimum value. That's 50. The maximum value, that's 550. The middle of the bottom half, notice there's 7 values, 1, 2, 3, 4, 5, 6, 7. That's Q1. I'm going to just kind of change my labeling just a little bit. Whoa. This is the minimum. Remember, this 125, we had to actually figure it out. That's our median. The median is also sometimes called the second quartile. It's the middle. Half the data is below it, half the data is above it. And in the middle of this, 1, 2, 3, 4, 5, 6, 7, is going to be this 150. That's Q3. So it's like we tried to take our data and divide it into 4 equal sections. First, we needed to find the median, and then we look at the bottom half of the data. We find the median for the bottom half and the minimum value, and then we look at the upper half of the data. We find the median for the upper half and our maximum value. And we're going to put all of those on that graph. I'm going to write them down here on my notebook paper. 50, 75, 125, 150, 550. So there's the 50,000. Our next one should be at 75,000. So that's Q1. Our next value is at 125,000. That's our median. We have one at 150,000. That's Q3. And then way over here, we have one at 550. The way you make a box plot is you draw a box that connects Q1 and Q3. Remember, that value was Q1. This was our median, and this value right here was Q3. Whoops, let me see if I can just write up median. It's right there, that line. And then if we draw, these are the whiskers you sometimes hear about to our box plot. Whoops, we lost our line here. That's a box plot. It's interesting because this part right here has 1/4 of the data, or 25%. This box right here is 1/4. This is 1/4. And then we have 1/4 stretching way out over here. You can see this is a case where we definitely have this long, drawn-out tail. Very definitely skewed to the right because of that one value. It says how many data values are at or below the median value? What percent of the total number of values does this represent? We had 14 data points, so 7 were below the median, and that was 50%. That median is that half above, half below point. How many of the data values are at or below Q1? In this case, if we include Q1, there were 4 data values. What percent of the total number of values? This region on our box is 25% of the graph. There were, if we count the ones at or above Q3, there were 4 at or above. And of course, that's the upper 25%. How much of the data is between Q1 and Q3? That's the middle 50%. It says find the mean of the data values to the nearest dollar. So we're going to have to go back and look at those data values. They did the mean for us. They added them all up. It was 151. I'm going to round that to 643. $151,643. It says use the information from questions 5 to 8 to write a short news report about the home sales. Here's a short. It says a succinct news report will mention that the majority of the homes sold for the values ranging from $75,000 to $150,000. That's that middle 50% from Q1 to Q3. A news article that uses the median rather than the mean as the average will report a more accurate picture. A colorful news article might mention the sale of the lakeside mansion for over $500,000. So a sample answer might be, the median home price in May was $125,000. Half the homes sold for less than $125,000 and half for over. The mean price was $151,643 because there was one home sold for a much higher price than the other homes. 14 homes sold during the month. All right, I hope that gives you an idea of mean, median, and mode. And I hope you understand that box plot that takes your data and divides it up into quarters.